Just as we were able to use reasoning to prove that triangles are congruent, you can also do the same to prove triangles are similar. And the three criteria that we learned yesterday were angle, angle, side, 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 or side, angle, side. The one that we're really going to use in these proofs, though, is only angle, angle. I'll show you one proof that involves side, angle, side, but all the proofs that you would ever do would just be angle, angle. The other ones are really rare in a proof. So in this exercise, I know that BD and AE are drawn, and they intersect at C, and it's known that AB is parallel to DE. So just like in a proof, we have statements on the left, reasons on the right. My first statement is that the lines are parallel, because that's the thing that's going to be able to give me some steps here. So if those lines are parallel, then basically AE and BD become transversals. So angle 1 and angle 2 down here are alternate interior angles. Angle 1 is congruent to angle 2, and the reason is alternate interior angles are congruent. We know the lines are parallel, therefore those alternate interior angles are congruent. Now I also have the angles by B and C are also alternate interiors, so you could have done that as well, and then you basically would have been done with the proof. But I just wanted to reintroduce these angles right here, 3 and 4, are also congruent to each other. So angle 3 is congruent to angle 4, so we did this all the time when we did congruent triangle proofs. Those angles are congruent because they're vertical angles, and vertical angles are congruent. Okay, but as I said, B and D are also alternate interior angles, and then you would not need step 3 if you had done that in step 2. And therefore my triangles are similar to each other. So triangle ABC is similar to triangle EDC, and the reason is just simply angle, angle. So I have two angles of one triangle congruent to two angles of the other triangle. So the triangles are similar. Their angles are congruent. Their sides are in proportion. All right. So very often the case when trying to prove that two triangles are similar, we simply need to establish that two pairs of angles in the triangle are equal in measure. All right, and that's the way that we're always going to be doing it. So in this triangle, I have MN is congruent to MP. So MN is this whole side right here is congruent to MP. So think about it, all right? That would make that triangle MNP, an isosceles triangle. Therefore, angle N and angle P, which I could just call angle M and angle P, but I put a 1 and a 2 there, are equal to each other because those are the base angles. So it's an isosceles triangle. All right, so angle N, or angle 1, since I already wrote a 1, is congruent to angle 2. All right, they're the base angles. Let's see what I'm actually trying to prove. I'm trying to prove NTR, which is this triangle on the left right here, is similar to PWS, which is this smaller one right there. All right, so this just says explain. It's not like a real proof. They also tell me that RT is perpendicular to NP and SW is perpendicular to MP. So basically that would make this angle right here, angle 3 and angle 4, right angles. All right, since the lines are perpendicular, then angle 3 and angle 4 are right angles, and they are congruent. Therefore, those triangles are similar by angle, angle. All right, now let's do a little math. So if RT is 12, so that's 12 right here. PW is 3, that's 3. And SW is equal to NT. I don't know what SW and NT are, but they're equal, so I can therefore just call them both X. So NT is here and SW is here. All right, so since the triangles are similar, I prove that in step A, the sides are in proportion. So from the bigger triangle, I'm going to take that vertical line 12, and I'm going to take the base X. And then from the smaller triangle, I'm going to take the vertical line, which is X, and the base, which is 3. As long as you're consistent and you're putting the same thing on the top and the bottom each time, then you're all set. How do I solve a proportion? I cross multiply. X times x is x squared. 12 times 3 is 36. I take the square root of 36, and x equals 6. Okay, there's actually two answers, positive 6 and negative 6, but I'm talking about the length of a side of a triangle right here, so I'm just going to use that that positive answer. I'm not going to use the negative one. So I'm just going to look at exercise 3, but we're not going to really do it. So it's just saying that angle is usually the way I'm always going to do a similarity proof, but it is rare. Sometimes you can have the sides being in proportion. So what's happened here is I have two triangles, all right, and C and B are connected to form segment BC, all right. What else did they tell me? Did they tell me what angle must be congruent between the two angles? You can see that they both share angle A. Okay, so angle A is shared. Therefore, it has to be congruent. And basically, if this is, I think they told us it was a midpoint or something. They were has been marked as C and B, connected to form BC. Draw and sketch the triangles separately. If they told us that C was a midpoint, okay, then that would mean that AE is 2 times AC, and if B was a midpoint, then that would mean that AD is 2 times AB. All right, so therefore those sides would be in proportion, and if the sides are in proportion and they have that angle between them that's congruent, then technically I could use side angle side to prove that these two triangles are congruent. I will never give you a proof like that, though. All of your proofs with similar triangles will always, always, always be angle. All right, so we're not going to worry about exercise 3. Exercise 4, I have a parallelogram. Point P is located on side CD. AP and BC are extended to point M where they intersect. I want us to give an argument for why triangle MCP, so that's this tiny one right here, that's my dog loudly chewing on a bone right there, is similar to MBA. So MBA, it's similar to both ADP and MBA. So I want to know why it's similar to this one and why it's similar to MBA, which is the whole big one right there. Okay, so again, it might just be easier to do a regular proof. So I know that it's a parallelogram, so ABCD is a parallelogram. If it's a parallelogram, then those opposite sides are parallel. So AB is parallel to CD, and AD is parallel to BC. That's the definition of a parallelogram. Because if I say that those sides are parallel, then all of a sudden I can have angles. I'm always looking for angle when I'm trying to prove similar. All right, so let's put some numbers on my picture right here. So that would make these angles here, angle 3 and angle 4, congruent to each other. All right, those would be alternate interior angles. And that would make angle 6. I'm going to put 1 and 2 here. I'm just trying to match it up to my picture that I already have. That would also make 6 and 7 congruent to each other. And I also have a 5 over here. And that was a 4 down there. All right, so angle 3 is congruent to angle 4 because they are alternate interior angles. All right, angle 6 is congruent to angle 7. So I could put these right here because they are corresponding angles. Remember, those sides are parallel to each other. I'm trying to prove that they're all similar at the same time. And angle M is congruent to angle M. Those two triangles share angle M. So just like we did that for a shared side, this is a shared angle. The reason is still the same though, it's reflexive. You definitely should all be able to get angle 1 congruent to angle 2. Those are my vertical angles in the middle right there. So vertical angles are congruent. I forgot to mark 3 and 4. I'm running out of lines right here. That was my step 3 that I already had. And that's enough. So basically, between the small and the medium triangle, all right, I have angle, angle. So they're similar. So triangle MCP is similar to triangle ADP by angle, angle. All right, have angle 3 and 4 and 1 and 2. And triangle MCP is similar to triangle MBA. That was the really big one. And that's also by angle, angle, because they share angle M, and 6 and 7 are corresponding. Okay, so we'll work with some more of these tomorrow.